Hello, welcome to Introduction to Engineering. In engineering, we're going to be introduced to a lot of different concepts. And this first concept that we're going to talk about for the first part of the semester is going to be energy transfer. Um, and one of the reasons why we're going to talk about energy transfer is because this is really going to be foundational to our understanding of what engineers do. In this course, we really want to prep all the students to be able to understand what they can be learning and doing in all of their subsequent science classes now to be a better engineer and be better prepared for engineering in the future if that is something that they're going to want to do. A lot of these concepts are going to be high level. It's not going to be a lot of college level math or anything. It's going to be more on the algebra side. But these concepts are going to be foundational so that when they are introduced to them later on in their education, they already know how they're going to be applied in future positions, engineering, etc. So this first one is we're going to be talking about energy transfer. How do we get energy from one location to another? How is it that if I'm able to push one button, I'm able to get a result on the other end? This is all very foundational for engineering, introduction to energy transfer. There's a quote that I like to share here from the scriptures in Moses, actually. And it says, "For I, the Lord God, created all things, of which I have spoken spiritually, before they were naturally upon the face of the earth." And understanding energy in this form is actually understanding kind of the spiritual aspect, the spiritual existence of matter. And then there's going to be the practical and how that will turn into something useful. Energy's out there. Energy already exists. It can't be created or destroyed. And as we understand how it exists and how we can transfer it into different things, we'll be better equipped to manipulate it in a way that can bless people's lives. So just going through, we're going to first talk about what is an engineer. What do engineers do, and really how does the world see an engineer? How does the industry, how do employers see engineers? But also how really what does an engineer do, and who can be an engineer? The next one, we're going to go all the way back historically and talk about the fundamentals. We're actually going to talk about the most important invention in human history, which is the shaft, and why it's the most important invention in human history. After that, we are going to get into energy transfer and how energy can transfer from different from one energy source to another, and how that has been helpful to us as humans, especially since the Industrial Revolution. After we talk about energy transfer, we will then talk about energy generation. How do we generate energy? Which one's the easiest form to generate? And then how can we transfer that into something that's useful? So to begin, what is an engineer? So in Wikipedia, it says engineers, as practitioners of engineering, are professionals who invent, design, analyze, build, and test machines, complex systems, structures, gadgets, and materials to fulfill functional objectives and requirements while considering the limitations imposed by practicality, regulation, safety, and cost. So that's Wikipedia's definition. If you ask 1,000 different employers, they'll probably give you 1,000 different answers, and it's basically going to be based off of their needs. But really, engineers, as is used in the workforce and in the industry, it's kind of this catch-all term for someone who figures things out, that invents, designs, analyzes. You can see this is a pretty big definition. But I would like to introduce a definition that I found very helpful that my uncle told me is an engineer. He never finished college, but he's one of the smartest people I know. He was taking apart computers back in the 90s and putting them back together bigger and better, and he knows everything. And this is his definition of an engineer. Someone who takes a large, complicated problem and breaks them into many smaller and simpler problems. So it's not, it doesn't have to be very complicated. Really, what an engineer does is take something that's really big and complicated and is able to break them down into bite-sized problems and be able to isolate them and tackle each problem individually to be able to solve a much larger complex problem. So for an example, building the Golden Gate Bridge. How do we get cars from this side to this side without having to drive all the way around? Okay, well, we're going to have to do a bridge. All right, well, how do we suspend it? Are we going to put posts in there? If we're going to do it, are we going to put posts in the water so it's supported, or are we going to have it suspended all the way out? What kind of materials are we going to use? And so they start asking all these questions, and each one of those problems, the bridge is one big complicated project, but as they start addressing each thing one by one, they're able to address all of the issues that are involved with building a bridge. Another example is a cell phone. How do we get a cell phone to turn on and do everything that we want to do? Well, there's an engineer that was assigned to one specific function. Maybe it was the camera, or maybe it was the flash, or maybe it was the battery consumption and optimization. And each one of those, we're able to break them down into little aspects and problems that were easily digestible. So at the end of the day, the engineer is just someone that's able to take a big problem and break it down into smaller, digestible problems. So now let's go ahead and talk about energy and invention, the biggest invention in world history that has contributed to our ability to harness energy. And that is the shaft. I know a lot of people say the biggest invention was the wheel, but I'm on team shaft over here. I believe the shaft is what enabled the wheel to actually be useful. Before the shaft, a wheel was simply a disc that could move around. But what was a shaft able to do? One of the things is that it actually helped us reduce friction. That combined with the wheel on being able to transfer loads, say uphill or downhill. It reduced the surface area, but was able to turn the need for a linear movement into a rotational one without it being too complicated or inefficient. It was very inefficient to put load a lot of weight onto a sled or something, and then pull it or push it down a hill or even on flat ground. And a shaft allowed for a more efficient way of doing that. The other thing that a shaft is able to do is it was able to transfer energy and movement from one location to another. If I spin two objects, or spin an object over here and it's connected by a shaft, then over here we're going to have another movement that is transferred through that shaft. It's really something very foundational, very fundamental. We don't really think about it, but if you start paying attention to where shafts are and all these different gadgets and everything, you'll see that it is pretty much everywhere. Another thing that shafts are able to do is it is one of the foundational tools to transfer energy. In this case, we have a camshaft that is found in a vehicle, in a car motor. This is kind of the basic concept of how we get chemical stored energy that turns into an exothermic reaction. Exothermic just means heat that creates an explosion and that energy pushes a piston out, and that's just linear energy. That by itself doesn't do anything. That's not going to turn a wheel. It's not going to turn on a light. It's not going to do anything. But when it's connected to that shaft in this type of orientation, that end result is, at the end, we have a shaft that starts spinning based off of how much of that fuel is combusting. And that allows us to transfer many different kinds of, well, a lot of different energy to the wheels, to the alternator, to radios, to the lights. Everything starts from that, and that shaft, it enables us to be able to have a lot of energy from that car. The other thing that shafts enable us to do is generate electricity. I kind of alluded to that with an alternator, but this is a basic, the basic idea of a steam turbine generator, which is you get hot water, you boil it, and then you send the steam through a turbine which spins that shaft. Okay? And that shaft, anytime it starts spinning, if you put some coils, some wire around magnets that are spinning around each other, it actually generates electricity. And this is how all electricity is generated, is whether it's a wind turbine or if it's a nuclear turbine or a diesel turbine or any of those. All it's doing is it's a bunch of different fancy ways to figure out how to turn a shaft to be able to generate electricity and turn on the lights in people's homes and power all their electronic devices. So as you can see, the shaft is really the most fundamental thing there, and it's that small problem that is solving big complex issues like powering a city. So in the something to keep in mind as we're talking about energy transfer, the fun kind of the breakthrough understanding historically for energy transfer was by Sir Isaac Newton. Energy is not lost or destroyed; it is merely transferred from one party to the next. So that was Newton who basically posited that. Before, the thought was that you could actually destroy energy, and that and so that when we thought that we could destroy energy, it actually we weren't oriented to ways of capturing and generating energy, because if it wasn't there, then if we couldn't see it or feel it or whatever, then we didn't think that it could be captured and harnessed. And so this was an interesting discovery and an interesting kind of change of viewpoint, that you can't destroy it. You can either use it or lose it. And so a lot of the Industrial Revolution was based off of using the energy that was being lost, not necessarily destroyed, and how to recoup a lot of that. So now in this course, we're actually going to go into the first part of this course is going to be spending 1 week on different forms of energy generation. Okay, and as we go through each form of energy, we're going to fill out an assignment that where we're going to kind of learn a very good overview of each form of energy generation and how it helps modern life. Okay, we're going to be answering questions like, how is this energy measured? How is it generated? And then is it a renewable or is it a non-renewable? And then also talk about a couple of examples in the world, and write a little essay, a mini essay on each one of these, on where they are, kind of what you're, maybe even an opinion on it. So there is going to be a little bit of writing, but really what we want to do is just understand each of these and put this type of energy in our toolbox of understanding, so that when we're making decision on what kind of engineer we want to be, it all focuses on the type of energy that you want to be. You have nuclear engineers, electrical engineers, mechanical engineers, chemical engineers, and really the difference between all of those is what type of energy do you want to study? Okay, so the first type of energy that we will discuss is mechanical, and that is traditionally broken out, and all of these are broken out by potential versus a physical version. So a storage and a stored version of the energy versus um, a physical version of the energy. But mechanical is kinetic and potential. The next one that we will talk about is electrical energy. What kind of, how is that measured? What exactly is electrical energy? What is it able to do for us? I think that's something that we definitely understand in today's world, but also how is it generated? What's the best way? And what are kind of the demands and conditions necessary for that? The other type of energy is chemical energy. I kind of talked a little bit about chemical energy with a combustion engine, but that chemical energy really helps us store things very well and create reactions that in conditions that help us make things useful, like a combustion reaction. Thermal energy is kind of downstream from chemical energy, but it's basically heat. How are we able to harness all the energy that happens from heat? And also, how is it generated? Sometimes heat is the unintended consequence of other forms of energy. So, for example, friction inside of an internal combustion engine. A lot of work is done to try to reduce the friction so that you don't burn up through parts through the thermal energy that is generated. And so, thermal energy is kind of a two-edged sword, as are a lot of these. The other one is kind of similar to thermal energy, and maybe it's a cousin of thermal energy, but it definitely is its own category, and that's nuclear energy. There's been a lot of talk about nuclear energy, and a great movie that just came out, Oppenheimer, about the father of the atomic bomb. But nuclear energy is also one of the cleanest and most efficient sources of energy that we have. Basically, it's you get a bunch of atoms that are breaking apart or being forced together, and they just kind of perpetually just heat up. And this heat is able to then create hot water that is turned into steam, and that steam turns a turbine, and that turbine generates electricity. And so nuclear energy is kind of just like that chemical nuclear. It's actually a nuclear reaction that's happening at the nuclear level of the cells to generate energy. Okay. Another form of energy is acoustic or sound energy. And so that's going to be interesting, talking about the uses of that. How does that transfer? Is it an efficient form of energy? What units are used? Stuff like that. The other is wind energy, which again goes into the turbine and things like that. Solar or light energy. Those are similar. Solar is light energy, but not all light is solar energy. It just depends on the spectrum of wavelengths that we're talking about. But we do know that light can generate energy. We know that it actually gives humans more energy. So when you're out in the day versus at night, people usually have more energy, and a lot of that is due to the light that's around them. Hydro energy, so water. So that's basically dams that falls off of a cliff and turns a turbine to then generate electricity. But there's other forms of hydro that's not necessarily using a dam, but also maybe even kinetic energy. So we'll talk a little bit about hydro energy and kind of the considerations with that. And then the last type of energy that we're going to be talking about is digital and informational. Now, I wanted to include this because this is probably the most widely used, but it's not necessarily considered a form of energy. But if you look at digital information and coding and all that, really you have a form of information that is basically able to be transferred and manipulated to create another output. And so just understanding that um, that in generation, we're in a world with artificial intelligence and a lot of IT, information technology, that relies on the understanding of the flow of information and digital energy that does exist and follows a lot of the same characteristics of our basic understanding of energy. Okay, so anyway, I hope you enjoyed this little lesson and quick overview, and piqued your interest for being able to go in and dive into each individual source of energy. Now, the rest of this course, we are going to have a project that will discuss and give us an opportunity to generate some electricity of our own. And the students will have to come up with a way or various different ways to turn a shaft or a turbine to turn on an LED light. And so that's going to be really fun, and we'll go through it and talk with it. There'll be a couple of kits to purchase of magnets and coils, and this was a project that I did in my 5th grade science fair project, and that was foundational, just seeing how that was put together and wrapping the coils around the magnets and seeing that transfer was really foundational to my understanding throughout my career and education as an engineer. So I hope you enjoy that, and we'll see you next week. Thank you.